Hello, in this lecture, we shall be looking at Chapter 10, Lesson 5, Instrument Identification and Numberings. To identify, examine, interpret, or draft P&ID, the selection of standard and code is important. Whatsoever the standard and the code selected for the task, there should be consistencies to avoid complexity or inaccuracy in the P&ID report. Let's study a simple P&ID. The task here is to identify and interpret the instrument symbol in designated P&ID diagram. In defining the terms as regards the instrument symbol, we need to know how to identify, interpret, and draft these symbols. The type of instrument being represented, the state of the system and the instrument under study, the functions of the instrument, the location of the instrument in the field. Generally, instrument identification can follow the below format. Nevertheless, depending on the standard and code selected. For illustration purpose, instrument identification format can be in this form. Take for example, assuming the general format for the instrument, the V, PIC, Z, YY. Here, the first letter here, which is the V, represents the system number. The second identification here, PIC, represents the function identification. The third number here is the unit code, and the fourth, which is YYY, is the sequence number, and the fifth is the letter suffix for identical system or equipment where specified, and the sixth is the letter suffix for functional identification or parallel equipment where required. Understand instrument symbol and control symbols. 2 to 4 letter code are used to describe an instrument or controller in the P&ID. The first letter indicates the initiating or measure variable. Subsequent letter read out the measure variable. Example, for illustration purpose, PIC. The P is the measure variable. The IC and the readout of the measure variable. Pressure indicator controller. Pressure indicator controller. However, the number or letter located at the bottom half of the symbols are called loop identifier. Loop identifier display where the instrument is located within the field. Here, in describing their location, this particular one represents field mounted. There is no line. Here we have a thick line, which shows this particular instrument is board mounted, and we have broken line, which shows the instrument is hidden or inside a panel, a board. Taking a look at this particular one, taking a look at this symbol, the instrument symbol, we can describe the F inside here as variable being measured, while the IC is the readout of the variable being measured. Rectangular symbol show that it is shared display, shared control instrument, and the location is board mounted, and the 105 is the control loop at the number or the loop identifier. Understanding instrument symbol and identification standard help to understand instrument symbol on process schematics. Consider this instrument with this label V, PIC, as explained before. The V here is the system number. It could have been Y, 10, 20, whichever number that is used. As long as it's positioned here, it represents the system number. The PIC, which is the next number here, represents the functional identification, which is here in this case we have the pressure indicator controller. It could have been flow controller, flow indicator, pressure transmitter, pressure indicator, temperature indicator controller. The Z here represents the unit code, and the YY here represents, we can take any form, represent the sequence number, and the B represents the letter suffix for identical system equipment when specified, and the A here, and the A is the letter suffix for a functional identification or parallel net when specified. There are some cases where identification just show information about the symbol as denoted in 3 and 4 below. Take a look at this instrument labeled PIC, Z, YYY, B-A, as you can see here. From the naming convention, it shows the system number is not part of its labeling. Hence, we have the function identification, the unit code, the sequence number, the letter suffix for identical system. We have the letter suffix for the function identification. This is just for illustration purpose. In another illustration, as you can see in this particular one, the labeling here just shows this instrument has two labels. From the naming convention, it showed the system number is not there. It also showed the letter suffix for identification system and the letter suffix for functional identifications are not here. This instrument have just the functional identification and the sequence number. Example of some letter combination. Here, for instrument to be fully defined, we will understand how the letter combination will work. We have the process measures. We have the process measurement, the element type, an element, transmitter, indicator, indicator controller, control, ratio controller, record. How do we combine this to define the instrument symbol? Take for example, for a flow, which is F, the element type is F. If I combine F with A, it becomes flow element. If I combine F with T, it becomes flow transmitter. If I combine my F with IC, it becomes flow indicator controller. If I combine my F with C, it becomes flow controller. If I combine my F with FC, it becomes flow ratio controller. If I combine my flow with recorder arrow, it becomes flow recorder. However, this is just for illustration purpose. Here we have the time and the element type is K. Here I have my time element, time transmitter, time indicator controller, time controller, and so on. So it is also applicable to every element or process measurement. In practice, the first letter indicates the initiative or measure variable. The subsequent letter read out the measure variable. The measure variables of the first letter can have a modifier which can be defined by the user. From table 10.5.4.1, the K as described above as the first letter indicates a measure time variable. It can be time rated modifier. For illustration, we have the temperature combining with the recorder, then we have the temperature recorder. In the succeeding letter, the readout narrative has a preference over the output function and the modifier. The measure variable is read out not without the unit of measurement in the mind, at least for record and documentation purposes. Example herein, the TRO is temperature recorder. The unit of temperature can either be in Kelvin, Fahrenheit, or degree centigrade, whichever way. Let's look at the FIC combination, for example, in table 10.5.4.3. The first letter indicates the initiative of measure variable, which is the F. The next letter, IC, fall into the subsequent letter column, which read out the measure variable. Hence, we have flow indicator controller. For CI, for example, in table 10.5.43, the C indicates the initiative of measure variable. The next letter, I, as the subsequent letter, read out the measure variable. Hence, we have conductivity indicator. Here for the flow, we have FIC. Here we have flow indicator controller, as explained already. This procedure is applicable to other instrument and instrument control identification. Tagging. A tag number or instrument identification label is the combination of letter and number that contains information for the component being represented. A tag is also referred to as labels or instruments or component labeling in process plan. Let's take a look at the tag number PIC 105 for illustration purpose. Here, PIC 105 is the instrument identification or the tag number or the label of the instrument. The PIC represents the functional identification. P is the pressure, is the first alphabet letter. IC is the succeeding letter. I is for indication and C is for controller. 105 is the loop identifier number or an instrument number. The line across the cycle shows where the instrument is positioned in the field. However, in this loop, the number 10 indicates the instrument location and the number 5 is the instrument number. If the instrument, for example, has 3 or 4 letters, the second letter will provide information about the first letter. Example below is the pressure differential alarm high, PDAH. pressure differential alarm high. Here, the PDA represents the differential pressure alarm that is activated when the pressure is high. Tag number, the PDAH105 is the instrument tag number ID or labeling. PDAH is the functional identification. The P is the pressure, D is the differential, A is the alarm, and H is high. 105 is the loop number. Let's look at another method of tagging. Let's take a look at an instrument with the identification or tag number 20 PIC10501A. Here, the 20 PIC10510A is the tag number. 20 is the instrument position number. May not be revealed on the P&ID, but as a comment on the paper stating the instrument belongs to the location as tag. PIC is the function identification or function ID. P is the pressure as the first letter, succeeding letter, and the I is stand for indication, and C for controller. The 105 is the loop number or loop identifier. The 01 is the optional surface or spare instrument, and A is the spare instrument. For multiple spare instruments, the letter distinguish the different available instruments. Take for example 20 PIC10501A, B, C. Simply represent instrument 20 PIC10501A, another instrument 20 PIC10501B, another instrument 20 PIC10501C selectively. Let's take a closer look at the below P&ID in the figure below. We can identify and interpret the various tags used in the diagram as indicated. So I will be starting from the feed A, then feed B, then the stream feed, and then we'll talk about the output hearing. This is just for explanation purpose. For independent control system of feed, here we have the feed A coming in, and we have this symbol here, and we have this symbol here, and we have this symbol here too, and this pneumatics line symbol. We also have the symbol here, which is 18, and the LIC symbol, TIC. We have the FT symbol here, and we have the TT symbol and the TI symbol. And come to the upper part here, we have the PIC 105 symbols as indicated here, the PT symbols as can be visualized. In this illustration, the LT here, LT015, is a level transmitter LT connected to level indicator controller LIC electronically, LIC 105, located in a share from the symbol control share displays, and the LT is feed mounted. As you can see, the output signal from the LIC 105 is a pneumatic signal which goes to the valve being the final control element. The LAH and the LAL here represent low alarm high, low alarm low. From this symbol, we can see that the FIC105 is a flow indicator controller. Hence, the FT105 is a flow transmitter connected to flow indicator controller, located in a shared display, shared control, shared display devices. The FT here is feed mounted, and this too is feed mounted, as you can see. Coming to this point, the electrical or the electric signal from the FIC, LIC, PIC are converted to pneumatic signal to control the valve FF where applicable. Here the TIC 105 is the temperature indicator controller. TI is the temperature indicator, and the TT is the temperature transmitter. The PIC 105 is the pressure indicator controller. The PT is the pressure transmitter. The valve here, the valve will open when the signal from the TIC and the FT read their set value. This is for illustration purpose. I leave you here with quick exercises. Thank you. See you again in chapter 10, lesson 6.